Around 16,000 years ago, some groups began moving south. They followed retreating glaciers along the Pacific coast, using boats and shorelines to navigate. This coastal migration likely brought the first humans into the Americas long before the inland ice-free corridor was fully open. Others may have taken the interior route later, moving through valleys carved between glaciers. Either way, these early migrations spread people rapidly across the continents. Within just a few thousand years, descendants of Beringian pioneers were living everywhere, from the Canadian tundra to the Amazon rainforest, from the deserts of the Southwest to the mountains of Peru. This vast dispersal gave rise to the first great branch of our story, the Native Americans. Their DNA, shaped by millennia of isolation on these continents, carries markers that link them back to their Asian ancestors, but also distinguish them as a unique population. Y-DNA haplogroups like Q and mitochondrial haplogroups like A, B, C, and D show the fingerprint of that Beringian bottleneck.
But what about the Inuit? If they share the same roots, why do geneticists say their story is different? Here's the twist. Inuit DNA doesn't come solely from those first migrations. Instead, their genetic profile shows evidence of a much later wave of migration, one that crossed into the Arctic thousands of years after Native Americans had already spread south. This later migration is associated with what archaeologists call the Paleo-Inuit or Dorset cultures, and eventually the Thule people, ancestors of modern Inuit. Their DNA reveals ties not just to ancient Beringians, but also to Siberian and Arctic peoples who remained in Asia long after the first Native Americans had departed. In other words, while both groups sprouted from the same Beringian roots, their branches split and evolved separately. Native Americans carried the story south into two continents. Inuit branch circled back, reinforced by new arrivals from Asia, adapting specifically to the Arctic environment.